Swayam Prabha. Digital India. Educated India.
Hello dear students. So today we are going to discuss about the Mahoney's table. The Mahoney's table is a simple tool for understanding the passive techniques for a given particular climate or location. So today we will see how to use this tool. What is this tool all about? So the Mahoney's table is a set of reference tables used in architecture as a pre-design analysis and guide to climate appropriate designing. The various tables are used in this type of analysis, which has information pertaining to the climate of the place. So there is data about the climate of the place. Then there is thermal stress analysis. What happens at what temperature the people there would feel very warm, or at what temperature will it be determined as cold, the way we saw in our thermal comfort class. Then determination of remedial measures, and then design recommendations. So the Mahoney's table comprises of these 4 parts. They are named after Carl Mahoney, who has worked on them along with Martin Evans and Otto Koenigsberger. These were first published in 1971 by the United Nations Department of Economic and Social Affairs. These tables use available climate data and have simple calculations incorporated with them to give the output of design guidelines in a manner similar to a spreadsheet. It's more like a Excel sheet as against simulation. There are 4 tables primarily. 2 are used for entering climatic data for comparison with the requirements for thermal comfort, and 2 are used for reading appropriate design criteria. So the data that is required for us to understand the passive techniques with the help of Mahoney's table, the first is air temperature. So you need to have data pertaining to air temperature. But what data? You need the maximum temperature, minimum temperature, and the mean temperature for each month. So for 12 months, you need the maximum, minimum, and mean temperature data. You also need the humidity, precipitation, and wind data of that location or place. Again, you need the maximum, minimum, and mean figures for each month, for all the 12 months. And the conditions for which each month is classified into humidity group. What is meant by humidity group? We will see as we progress in the class. Then there is a comparison of comfort conditions and climate. The desired maximum, minimum temperature are entered to get heat stress or cold stress. So from the temperature that is entered in the tables, you will be able to arrive at what is the heat stress or cold stress. That is, the building will be too cold or too hot. From the data, you will calculate the annual mean temperature or AMT, which is the average of the highest monthly mean maximum and the lowest monthly mean minimum temperature. So this will be T maximum plus T minimum divided by 2. I will be explaining all this in detail in the forthcoming slides, but I'm just trying to already familiarize you with these. The annual mean range or AMR is the difference between the maximum highest mean temperature and the lowest monthly mean temperature. So this is called as AMR. There are basically 4 tables. The first table pertains to entering the basic climate data. What basic climate data? That is something I have already told you in the previous slide. The maximum, minimum and mean temperature, humidity, wind data, etc. Table 2 pertains to diagnosis. Table 3 gives us recommended specifications, while table 4 gives us detailed recommendations. We also have a set of indicator tables. So what are indicator tables? Indicators are rules provided for combining the stress that you get from table 3 and humidity group from table 2 to check a box classifying the humidity and aridity of the place. Check a box. You just have to tick it. For each of 6 possible indicators, the number of months where that indicator was checked are added up, giving a yearly total. So for this demonstration, we will be using the climate data for Chennai city, which is the state capital of Tamil Nadu in India. It has a warm and humid climate, and the climate parameters required for Mahoney's tables are monthly average minimum and maximum air temperature. So you can see the average maximum, average minimum air temperature is entered like this. I will demonstrate it also in the forthcoming slides. So for January, what is the average maximum temperature? For January, what is the average minimum air temperature? And so on. Like this, you enter this till December. Similarly, you enter the average maximum humidity for January and average minimum humidity for January, February, March, April, May, June, July, August, September, October, November, December. Then after that, the rainfall has to be entered in millimeters for all the 12 months. The wind direction is further entered as primary wind and secondary wind for all the 12 months. So we will see this step by step. So first, this is how you will have the chart. The chart will be empty like this. In this, you should fill up this Chennai. This is all filled by you. So we will fill this Tamil Nadu and so on. Whatever data. Latitude. What is the latitude? 13.08 degree north. What is the longitude? 80.27 degrees east. And what is the altitude? 6 meter. So this is table 1 and it is used to record the most essential data for temperature. So the first step is input the monthly mean maximum temperature, which is the average of the maximum temperature recorded for each day of the month, and the monthly mean minimum temperature, which is the average of the minimum temperature that is recorded for each day of a month as given in the weather data that you collect. Then the next step is you find out the monthly mean range, which is the difference between monthly mean maximum and monthly mean minimum, and that will be entered in this row. So it will be like this. The monthly mean maximum and monthly mean minimum will be entered where I have marked in the red box, and then this is how it will look. So what is this data? This data is the maximum mean of January. It means that Jan 1 plus Jan 2 to January 31st, whatever is the maximum temperature of that day divided by 31, that is this data. The same thing, the minimum temperature average. So this will become minimum, and that average is here. Like this, we should fill in the monthly mean maximum and monthly mean minimum for each of the 12 months. Then after that, you have to fill the monthly mean range. What is the monthly mean range? Monthly mean range is the difference between monthly mean maximum and monthly mean minimum, which is, here we have seen the monthly mean maximum is 29.8. The monthly mean minimum is 20.1. The difference is 9.7. That must be entered here. In the same manner, how do you arrive at this? The monthly mean maximum for February is 31.6. The monthly mean minimum for February is 20.8, and that difference is 10.8. This must be entered in this row. Like this, the monthly mean range for all the 12 months must be entered. So eventually, what will happen? You will get a range of figures, and the highest of this, which is 37.4, the highest monthly mean maximum must be entered here, and the lowest monthly mean minimum must be entered here. So this is how it will look. And after this, after entering this, we have to calculate the AMT and AMR. So what is that AMT and AMR? I had already told you. AMT is the average of this and this. And AMR is the difference between 37.4 minus 20.1, that is 17.3. That must be entered here. So we get our AMT and AMR. Hope you all are following with me. Then we have to enter the relative humidity. Now the first step is you have to input the monthly mean maximum relative humidity and monthly mean minimum relative humidity as given in the weather data. Now in majority of the cases, only the average relative humidity values are available, and this can be used directly. So fill in the humidity group according to the categories given below. So how will it look? You have to feed the monthly mean maximum and monthly mean minimum, and then this is how it will look. For Chennai, this is the monthly mean maximum and monthly mean minimum as got from the weather data file. Weather data of Chennai will give this for various months: January, February, March, April, May, June, July, August, September, October, November and December. This is how it will look. After this, you need to enter the average. What would be the average here? The average here would be 93.8 plus 41.3 divided by 2. And like this you do for each of the months, and you will get the average relative humidity. Now look at this table and fill in the humidity group. Now that table says that if the humidity is 67.5, it falls under this category. So here you will simply write 3. Similarly, 67.1 falls in this category, it is 3. 67.3 falls in the third category, it is 3. And so on and so forth. This is how you will write. Now here you can see above 70. So this will fall under category humidity group 4. Similarly, this is 4 and this is 4. Like this, you will enter the values for each of the month. And this is how your table will look after you enter the humidity group. Next, what will happen? You need to enter the rainfall and wind. Now, rainfall must be entered only in millimeters, and wind here we are going to feed in direction of wind for all the 12 months of the year. We will feed in the primary wind direction and the secondary wind direction. Both must be fed in. So how will it look like? Finally, after you fill in the entire rainfall in millimeters, you add that and fill the total rainfall also, which here will be the addition of all the 12 months rainfall. That comes to 478 millimeters per annum. For that year, probably that was the rain. Next, you feed in all the data pertaining to wind direction. So all this is got from the local weather file. The local weather data will give you this information and the rainfall information also. After this, what you do? You move on to diagnosis. Now, this table 2 is used for diagnosis of the climate data and develop a series of climate indicators. So what you have to do is, you need to insert the monthly mean maximum and minimum temperature and AMT from the first data slide where we had written the humidity group. You remember that slide? From that, you have to write for each month. The next step is, by considering the value of AMT, you decide which comfort limit table is applicable. In the case of Chennai, we saw AMT is 28.8. We had calculated the AMT to be 28.8. So, in this manner, you fill the monthly mean maximum first, then fill the monthly mean minimum, and then you write the humidity group like this. You remember the humidity group that we had got? It was all 3, 3, 3 except for the October, November and December, which was 4. Then after this, what you should do is, you should write the AMT and check with the AMT given in this table. This is a standard table. So this is not something which you can enter. So everything which is gray in color is standard, which is part of Mahoney's table. Whereas all the non-gray white ones are where you have to enter the data. So you check this and then you write the humidity group, and based on the combination of AMT and the humidity group, what you should do? You should enter the upper limit and lower limit. So for an AMT of 28.8, which falls here, 28.8 is between 23 and 29, and the humidity group of 3, for this combination, what is the upper day comfort limit and what is the lower comfort limit. Like this, you write for each of the month. And again, for the same thing, you write the lower limit. For night comfort, what is the lower limit? It is 23 degrees and 17 degrees. Like this, you fill this entire row. So you can see for February what happens. February, it is again a combination of 28 and 28.8 and 3. And therefore, this would be the AMT which you have to fill in, day comfort and night comfort. But when it comes to October, November, December, the AMT is 28.8 and humidity group is 4. So this is what I'll change the color so that you will be able to understand. So for October, November, December, it is a combination of this AMT along with the humidity group. So you enter the range of 22 to 27 as day comfort, and the minimum as given here, it is 17 and 21. Like this, you enter in the diagnosis table. So after you enter this, it means, see, 29.8 is more than 29. So it means for January, the condition is hot. The mean is above the limit and therefore it is warm or it is hot. So you write thermal stress during day as hot. Like this, you fill for each of the thing. Now, you can see that 31.6 is more than 29. So it is bound to be hot. Like this, for each of the table, you fill it. Then you have indicators. So pick a month and take its thermal stress for day and night, rainfall, humidity group, and monthly mean range. We will take the example of May just to demonstrate now. Similarly, we will do it for all the months and tally it in the end. So for January, we know that the thermal stress during day is H and during night it is O. Rainfall is 5 millimeters, humidity group is 3, monthly mean range is 9.7. With this combination, you will get air movement is essential. So you will need air movement in January is what the combination says. The humidity group is 3. See, this is H. During day it is H. So you consider this. You see the humidity group as 3. So you consider this. And monthly mean range must be less than 10. So 9.7 is less than 10. Therefore, you will require air movement. That is what the indicator says so. So we will mark this as the indicator is H1 and we will mark H1 here. Let us look at what February looks like. Now, for February, again, the thermal stress during day is H. Okay, so can I take this? I don't know. The rainfall is 0. So rainfall is 0. Humidity group is 3. And monthly mean range is 10.8. So it cannot be this. It has to be more than 10. Therefore, we consider thermal capacity is necessary for the month of February. Then next we will go to March. During March, the thermal stress is H, hot during day and night. Rainfall is 0, which is Humidity group is 3. So it can only be either this or this. Humidity group as 3 is either this or this. We have to choose between these two. But monthly mean range is 10.9. If it were less than 10, then we would have chosen this. But it is more than 10. So we will choose thermal capacity necessary for March. So we will tick thermal capacity necessary for March. Then we will move on to April. During April, what is the data? The data is again thermal stress during day is H. Rainfall is 0. Humidity is 3. Monthly mean range now is less than 10. So here it is 9, which is less than 10. Therefore, we pick this box that air movement is essential, which is H1. So we will have to mark H1. What happens in May? In May again, if you see, monthly mean range is less than 10. Humidity group is 3. Day is H. So only this fits the bill and therefore air movement is essential. For April again, we get data which says monthly mean range is less than 10. 9.5 is less than 10. Then you have humidity group of 3, which again fits this bill, and therefore we will say air movement is essential. Then we will look at July similarly, and we will fill air movement is essential. What happens in August? Again in August, air movement is essential because monthly mean range is less than 10. Then we look at September, where again monthly mean range is less than 10, humidity group is 3, thermal stress is H, and rainfall is less than 56 millimeter. So we get H1. Similarly, we do for October, we will do for November, and we will fill for December. So we've got this indicator ready. Then we will add the total number of months under each of the indicator. So H1, there are 10 months in H1 and 2 months in A1. So what do these indicators mean? A1 means there is need for thermal storage. So this applies to places which has normally places which has large diurnal range. What is large diurnal range? Difference between day and night temperature is called as diurnal variation. Suppose the day maximum temperature is 40 degrees and night minimum temperature is 20 degrees. Then the diurnal range is 20 degrees. So this is diurnal range. If we look at A2, A2 indicates the desirability of outdoor sleeping space. Now it is needed when the night temperature is high and the humidity is low. It may be needed also when nights are comfortable outdoors but hot outdoors as a result of heavy thermal storage and when diurnal range is above 10 degrees centigrade. A3 indicates winter or cold season issues. So the Mahoney tables establishes a relationship between climate indicators and building design. H1 as an indicator indicates that air movement is essential. This applies when high temperature is combined with high humidity or when the high temperature is combined with moderate humidity and a small diurnal range. H2 indicates that air movement is desirable. It applies when temperature within the comfort limit are combined with high humidity. H3 indicates that precautions against rain penetration are needed and problems may arise with even low precipitation but will be inevitable when rainfall exceeds 200 mm per month. So let us look at the recommended specification. Based on what we saw, table 3, it translates the indicators into performance specification. So this is the indicator table. If you remember, we had to mark H1, tick against H1 and A1 and things like that. So this table 3 translates these indicators into recommendations. So check the requirements for each design strategy and tick wherever applicable. So here in this case, it looks like we need orientation north and south with long axis along east-west. And then you need sometimes protection from cold and wind. And you also need rooms single banked with permanent provision for air movement. Because we had the total number of months under H1 as 10 and total number of months against A1 as 2, if you remember in that slide. So once we add that, then this is the recommendation we get. Again, the openings can be medium openings. Then the walls can be light walls with short time lag. Because this is 0 to 2 months add up to A1. If it were 3 to 12, then we would require heavy external and internal walls. Again, when A1 is 0 to 5, light insulated roof is needed. A1 is 2 to 12, we require space for outdoor sleeping. If this were 2 to 12, then protection from heavy rain would have been necessary, but this is less than 2. Then further detailed recommendations also says that the medium size openings in north and south at body height on windward side, we should have the position of openings and we should exclude direct sunlight. So look at what correlates for the indicator that we have got, whether it is this or this or this or this. Like in this case, our H1 is 10, which falls under 3 to 10. And therefore, north and south at body height on windward side should be the position of the openings. So in this manner, we complete other things like walls and floors. So for this, we have A1. This is the criteria we will choose. Under this, it says that we must have light low thermal capacity. Our A1 is 2, 0 to 2. So it falls under this range, and also H1 is 10 to 12. This means we should have light reflective surface with probably cavity walls. Again, this is 10 to 12. So we could consider light and well insulated walls also. Like this, now we have seen for Chennai. I will demonstrate this similar thing but not so much in detail for Vadodara, which we consider as a hot dry climate, and I will also look at another cold climate and we will see what the outcome is. So for Vadodara, I have already filled the average maximum air temperature, average minimum air temperature, the average maximum relative humidity, average minimum relative humidity, average rainfall and the wind directions. So after filling this in the table, I have calculated the AMT and AMR and I have calculated their high and low here. I've also noted the monthly mean maximum and monthly mean minimum relative humidity and calculated the average relative humidity and entered the humidity group. Okay, say I've entered 2 because this falls in this category and so on. Like how I had demonstrated for Chennai, I've done this for Vadodara also. I've entered the rainfall and the wind direction and done the diagnosis. So when I do the diagnosis, I find that it is comfort and cold for January. It is hot and comfort for February and so on. So that is because of the combination of AMT and the humidity group. So an AMT of 27.5 with humidity group of 2. So this is the humidity group. So I need to check what data I should enter. This is what I will enter because the AMT, my AMT here for Vadodara is 27.5. So I will enter this range 25 to 31 and this range 17 to 24 here. And I will do the further calculations as I had shown in the previous. Then based on this, I am doing the indicators also. So after I do the indicators as I had already demonstrated, we go for recommended specifications. So here the recommended specification comes out to be in terms of layout, in terms of spacing, in terms of air movement. It says that the orientation should be north and south, long axis along east and west, and the spacing of building, it should be open spacing for breeze penetration, but there must be protection from hot and cold wind. Also it says that air movement, rooms should be single bank with permanent provision for air movement. Then when it comes to openings, we look at having medium openings of 20 to 40%. Walls must be heavy external and internal walls. Roof must be heavy roof with 8 hours time lag, and we should have space for outdoor sleeping. Also protection from heavy rain is necessary. That is what this diagnostic says. Okay, so don't judge me based on the data that we entered, got from the Met department. This is the diagnosis, and these are the detailed recommendation that the size of opening should be very small, and we should have the north and south at body height on wind side as the position of openings, and we must exclude direct sunlight. Also, the walls and floors must be heavy with over 8 hours time lag, and the roof must also be heavy with over 8 hours time lag. Then I will move to Shillong. Shillong we will consider as a cold climate. So for Shillong, I've got the climate data and I am entering that data. I have already entered the air temperature, monthly mean maximum, monthly mean minimum, monthly mean range. I've already entered the data. Similarly, I have entered the monthly mean maximum, monthly mean minimum, relative humidity data, the average data, and based on this, I have entered the humidity group. So this is above 70, so humidity group is above 70. So everywhere the humidity average is above 70, so the humidity group is uniformly 4 for all the 12 months. Then I enter the rainfall of every month and I get the total rainfall in millimeters. Then I will enter the prevailing wind direction and move to the diagnosis table. So when I see the diagnosis table as a combination of AMT and humidity group, I have entered the thermal stress based on the combination of this. So this is 4 and 16 will fall here. AMT below 15 degrees centigrade And here there is AMT, which is 25 to, so 16 falls here, no, between 15 and 20. So this is what I will be entering. So this is what I have entered, 20 to 25. And 14 to 20 is the nighttime comfort range. And based on this, I have also entered the thermal stress during day and night. So what do I finally get? I get the indicators which show that under H2 I have 10 months, under H3 I have 5 months, and under A3 I have 2 months. So based on this, the recommended specification is that we should have compact courtyard planning, we should have compact layout of estates, we should have double banked rooms with temporary provision for air movement, we must have large openings, the walls must be light walls with short time lag, roof should be light insulated roof, and the opening size should be large. The position of openings in north and south at body height on windward side. We must protect the openings from direct sunlight and provide protection from rain as well. This is what the recommendations say. It also says that we should have light, low thermal capacity wall, and the roof must be light, reflective surface cavity. So after this, what we will do is we will compare all the recommendations for the 3 climate types. Now, if you see the comparison, we see Chennai is warm and humid, Vadodara is hot and dry, and Shillong, Meghalaya is cold. Now, for warm, humid and hot, dry, it says orientation should be along north and south. Whereas for Shillong, it says compact courtyard planning. For warm, humid and hot, dry, it says open space for breeze penetration but protection from hot and cold winds. The same for Vadodara. Whereas for Shillong, it says compact layout of estates. The rooms for warm, humid and hot, dry is rooms with single banked permanent provision for air movement. Whereas for Shillong, it should be double banked room with temporary provision for air movement. The openings must be medium size for warm, humid and hot, dry. Whereas for cold climate, it says large openings 40 to 80%. Now, the walls for warm, humid should be light wall with short time lag. And for hot, dry, it should be heavy external and heavy internal wall. Whereas for Shillong, it should be light walls with short time lag. Again, roof for warm, humid is light insulated roof. Whereas for Vadodara, it is heavy roof with 8-hour time lag. Whereas Shillong, it says light insulated roofs. Provision for outdoor sleeping is required for warm and humid, and again for hot, dry, it says space for outdoor sleeping is required. And for hot, dry, it says protection from heavy rain. So what I am trying to say by comparing is most of the recommendations are valid, but these tables are not completely accurate, as you can observe from this slide, for 2 reasons. Reason 1 is it depends on the input values, input of temperature or the weather data file. Now, weather data has been changing because of climate change. Therefore, what you insert for 1 year may not be valid for all the years. Now, according to this table, it says protection from heavy rain is necessary for hot and dry climate. Now, hot and dry climate do not have much rainfall, but today we are seeing that there is very heavy rainfall even in desert areas. So for all you know, what this table says may be accurate, But actually logically it is not so. Therefore all that I am trying to say is that these tables give a fairly good thumb rule recommendations about what passive strategies we must use, but they also carry a small element of error, which is basically because of the data that we enter. Which year's data did you enter? So be very careful to enter data which is generic. Data of generic year should be entered, and not data where on some during some year there must be a, something which is out of the norm for that particular place. Do not enter that year to get your recommendations. So today we saw a very simple tool for which you do not require any major skill other than just entering the data and following the instructions that is given to you to arrive at decisions, and you will get all the thumb rules for simple passive techniques. So with this, I will stop today's class, and in further classes, we will see how when this is converted into an intense or what shall I say, a simulation software where all this and even more can be got. So we will look at that at a later stage, and for now, I will stop today's class. Thank you.